Welcome to the RAOB program's interactive sounding. All examples shown in this video require use of the optional Photograph and Interactive Program module. This video demonstrates how you can use the mouse to interactively change temperatures and winds. We'll first demonstrate the simple click and drag method using the left mouse button. Just move the mouse over the point of interest, like the 800 millibar temperature, and then click the mouse. And then you'll see a small text box displaying the data point's temperature value. You can then drag the mouse to any desired location. Also note that while moving the mouse, the stability bars change color as the lapse rate thresholds change category. In fact, in this position, we have an autoconvective region above and a stable region below. We can even change the dew point values with mouse movement. Okay, let's return to the original sounding by going up to the menu bar and select the Restore option. And now we'll see how you can add or delete sounding data with the mouse. As a reminder of the methods used, just select the Edit menu, then select the Add Delete Temperature Data option. If selected, then this menu option displays a small help file of instructions, which mainly says to use a Control left click to add data and a Control right click to delete data. So let's demonstrate how to add data. And let's add a data point just above the 700 millibar level. So we'll press and hold down the Control key and then left click the mouse. Notice that three things happen. First, a new temperature data point is inserted. Second, a corresponding dew point value is added, where RAOB estimates a representative value based on adjacent dew point data. Third, gray lines indicate the location of the original sounding profile. Once a new data level is added, you can then adjust the profile points with click and drag actions. And now we'll delete a data level by locating the mouse over a data point of interest, and then hold down the Control key and then right click instead of left clicking. And as we delete other data levels, notice that a small text box appears indicating the data level number that was just deleted. Okay, let's again restore the original sounding profile. And this time, let's alter the surface temperature. We'll first increase the surface temperature to the mid-30s, then release the mouse. Notice that after changing a surface value, a new hotspot menu appears just below the sounding diagram, called the Mix DALR layer, where DALR means dry adiabat lapse rate. When you move the mouse over this text, it becomes highlighted in a bright red and is underlined to indicate the hotspot menu can now be activated. So you can now click on this hotspot and a new panel of menu options appears. These options help simulate how a sounding may change during maximum heating events. We'll now click on the Mix button, and you can now see that the lower portion of the profile has been realigned with the surface dry adiabat value. Now we'll again restore the sounding, and this time we'll first alter the dew point value and then alter the temperature value. And now when we click on the Mix DALR layer hotspot, we again see the DALR menu panel, but this time we have an additional option which allows mixing of both the temperature and dew point profiles. So we'll select the option to mix both the temperature and dew point and then click on the Mix button. This time you can see the dew point profile is proportionally adjusted with respect to the same depth as is the temperature profile. So let's now again use the Restore menu to return to the original sounding profile. And now we'll add the classic data listing to the sounding diagram. And then as we interactively alter the 850 millibar data point, we can see many of the data listing values automatically change while the profile changes. And now we'll add to the display the parcel data box. And then as we interactively alter the sounding profile, the parcel data box values also change. Additionally, note that the title of the profile being changed is highlighted in red, for both the temperature and dew point values. Okay, let's restore that sounding again, because now we're going to do some fun stuff, which I want to point out can be very useful for both operational and educational purposes. First, we'll go to the menu bar and select the Analyze option to display the toolbar. Then turn on the significant levels and the lift parcel options, and then close the toolbar. Before changing any data, notice the positions of the significant levels and that the lifted trace is colored in blue. Now, let's alter the surface temperature and watch how the significant levels and parcel trace line automatically change as the surface temperature changes. And now we'll also alter the dew point value and watch the graphics correspondingly change. Alright, now we'll restore and refresh the screen again. And now we'll call up the toolbar with a mouse right click and select Icing, Clouds, and the Thermal Turbulence options, and then close the toolbar. And now we'll alter the cooler upper portion of the sounding and watch the clouds and icing graphics change. We can also change the dew point at lower levels to create cloud layers. And we can change the surface temperature to alter the thermal turbulence graphic. Now let's again restore and refresh the sounding, and then again recall the toolbar and select Inversions, Freezing Line, and Mixing Height options, and then close the toolbar. First, we'll start at the top and alter the freezing level, and at the same time we've created a frontal inversion. Then we'll create a low-level inversion, and at the same time we've altered the mixing height or PBL level. And one more time we'll restore and refresh, then recall the toolbar, and now select the wet bulb profile and the relative humidity options. We'll now close the toolbar and alter the 850 millibar dew point value and watch those newly added parameters change. Okay, it's time to have even more fun. First, we'll refresh and restore the sounding. Then we'll open the Displays menu and select the Special Severe Weather diagram. We can now alter the 700 millibar temperature and change the hail diagram. Then we can alter the surface temperature and change the storm character. And finally, we can alter the 500 millibar temperature and change the dry microburst potential. So now we'll restore and then go to Displays menu again and select the Special Winter Weather diagram. And here we see that we've also loaded a new sounding to demonstrate winter precipitation. So by changing the 800 millibar temperature to cause mid-level warming, we change a snow event into a mixed precipitation environment. Also notice how the thermogram reflects the warming layer as it crosses the freezing temperature. And now one more time, we'll restore the sounding and then go to the Displays menu, and this time select the Special Fire and Air Quality diagram. And here we see that we've also loaded a new sounding to demonstrate these diagram features. And as you would expect, by altering the surface temperature, you can produce significant changes in many of the fire and air quality indicators. And even the surface dew point has its effects. And now for the last interactive example, we'll load a different sounding. So let's recall the toolbar and select the CAT or turbulence option, the low-level wind shear, and wind speed options. And notice that there is currently no low-level wind shear detected. Okay, for these last examples, we're just going to alter wind data. So let's begin by moving the mouse over the surface wind. And notice that the mouse pointer changes its image into a plus sign. And when you click the mouse over this wind plot, it activates the interactive edit mode. This wind edit mode comes with its own display panel, which indicates that all changes are now made with the keyboard. For example, we'll use the up and down arrow keys to change the wind speed, which affects many parameters and the turbulence graphics. Then, we'll use the left and right arrow keys to change the wind direction, where the storm relative helicity values are mostly affected. So, we'll press the escape key to exit the wind edit mode. And let's also restore the sounding profile. Okay, remember how we could add and delete temperature data from the sounding profile using mouse clicks? Well, the same process works with wind data. Let's say we want to add a wind between the first two wind plots near the 1,000 foot level. To do this, we move the mouse to the desired height, then hold down the control key and then left click the mouse. Now the new wind is plotted in red, and the interactive wind mode panel is again displayed. Note also that RAOB interpolated the new wind's speed and direction from the two adjacent winds. And since we're in the interactive mode, we can now use the arrow keys to make final adjustments to the new wind. And then we can press the escape key to exit the interactive mode. And just like deleting the sounding profile temperatures, we can also delete winds. Just press and hold down the control key and then right click on the winds that you want to remove. And when done, you can use the File and Save menu to save your new sounding, or just click the Restore menu to return to the original sounding data. That completes the RAOB program's interactive sounding demonstration. Thank you for watching.